Hello and welcome to the final Mechanics 3 question. Mechanics 1974, question 3, which is the final question for this year. We'll be 1/39th of the way there. Alright, so we have a system here where we have a wall where the floor has no friction and neither does the wall itself. And usually the AP exam will denote this as no friction with these little dashes. We have a block M here, and then we have a spring, and another block M here. We have a spring constant K. And it wants to determine the maximum speed of the right-hand block. Now to do this, you need to use conservation of energy. I don't know really another way you would do this. Well, an easy way, that is. So we know the potential energy, we kind of had you before, is 0. It won't be moving. So it's only potential energy, which is 1/2 kd squared. And it's only moving at the end. There's no potential energy. So you have 1/2 mv squared. And this is only for the right-hand block, not the entire system. Just remember that, it's only the right-hand block. These 1/2s cancel, so you're left with kd squared over m equals v squared. I'm going to skip a step, which is just algebra, because v equals d times square root of k over m. Hopefully you got that step, because it's d squared, you can factor out a d. And then you can take it out of the square root. So for those who can't see, I'm sorry, I didn't realize how far my camera was. That's your answer right there. I'm going to write this over here just for reference. I know you might not be able to see it, but I just need it for future problems. We've already discussed how to get it. So that's problem part A. Now we talk about part B, which determine the speed of the center of mass. Oops, I almost erased part of my diagram here. Which would basically, if we think about this, the center of mass is at the center of these two. So this spring's a distance. It would be around here, especially since the spring is massless. You COM, center of mass. Usually it's denoted CM. So the velocity of the center of mass. So we have the velocity of the center of mass equals the mass 1/2. Actually, no, it would just be mv plus m0. This one's that instantly leaves the wall. So this isn't moving. One of these isn't moving, right? So we know that this term would cancel out. And we know that this would leave us with a velocity of 1/2 v. Now you might ask how we got that. Where did the m go? Well, remember, if this is the entire system, that's m. And we want just this one block, right? So we just take 1/2 m. Now we can talk about, all we have to do now is we have to plug in the v, right? So v of the center of mass equals d over 2 times square root of k divided by m. And that would be our speed of the system. So now I'm going to write this over here too, just so we know. In case we need it, you never know these days. Right? Never know. So let's take this out. And now we have to remember one thing. 1/2 then. We're going to realize this when we do the next part, which is finding the period of oscillation of the system. When the left-hand block is no longer in contact with the wall. So, if we remember our simple formula, 2 pi square root of m over k equals the period. However, remember this is m over 2, so all you have to do is plug in m over 2 for m, get m over 2k. And that's your period. And that problem is fairly simple compared to the rest of these. But do not be fooled. It does take some knowledge to solve. Alright, thank you for watching, and I hope you have a good